Okay, chapter 27 is on nutrition and metabolism. And if you have read this chapter already, you will see that it's a lot of information that is repeated from previous units. So if you recall, the very beginning of this textbook, when we were talking about chemicals and chemistry of life, a lot of the discussion about these molecules already happened before. So we're just kind of putting all of that together in chapter 27 here. So a lot of this is review, and that's why this session is not going to be that long. Okay. Nutrition is a study of how living things get nutrients, how they utilize these nutrients, and how they get energy from these nutrients. We can divide nutrients based on two criteria. We can divide them into macromolecules or micromolecules, or macronutrients and micronutrients, and then the other division is essential versus non-essential. So some of you have been asking like what's a good way of studying, or how to take notes, something like that. So I made for this first section, this is just an example of how I would make my notes here. Okay, where you can write nutrients, and then notice I like to use different colors. So I used this green color to divide them into macro and micronutrients. Then underneath it, I wrote what that means, and then some examples in the yellow for each category. And then the purple, that's the other division. Okay, so you see the essential and non-essential, and also underneath it, I write what it is. So whenever you're reading, you should be taking notes, okay? If you're just reading and not writing down anything, or you're not trying to organize the information, it might be very difficult for you to remember the information. So that's just an example, kind of a side note there of how usually I write my notes and organize my information as I go over this. So we have the macronutrients and micronutrients. Macronutrients are the nutrients that we need to consume in large quantities. So these are going to be including your carbohydrates, lipids, proteins are your macronutrients. And the micronutrients are things that you need in smaller quantities, like your vitamins or minerals. So that's the micro and macro division. The essential versus non-essential. This division is about how you're getting them. Okay. So essential nutrients you have to get from the diet, and this can be macronutrients and micronutrients. So we'll kind of talk about the essential, not essential as we focus on each nutrient. And then the non-essential things are molecules that you are able to build in your body. So again, we'll look at some of these as we're going over the chapter here. So let's look at the macronutrients first. And macronutrients are going to include, as I said, carbohydrates, lipids, proteins. A lot of this vocabulary, when we look at these groups, has already been discussed before. So again, this is just a review. So carbohydrates can be, you've already heard the monosaccharides, disaccharides, oligosaccharides, polysaccharides. These should be already known to you. When we're looking at the diet, we divide carbohydrates into sugars, starch, and fiber. Okay, sugars are going to be your smaller, your monosaccharides, disaccharides, things like that, like glucose. Starches are going to be polysaccharides, and then fiber is also a polysaccharide, but the fiber is a carbohydrate that we are not able to break down or digest. So that's the important stuff about carbohydrates. Okay, again, this is just a review. For lipids, you know that lipids are not water soluble. Okay, we already know that. Triglycerides are an important type of lipid, as well as we'll talk about cholesterol in a little bit. Triglycerides include fatty acids that are, or we can talk about like different groups of triglycerides, and they can be saturated, unsaturated, or polyunsaturated. And the difference between these is, where did I put my pen? The difference between the saturated, unsaturated, and polyunsaturated is in chemical bonding between carbon atoms. So let me kind of give you an idea of what I mean by that. So now the sharing of the Chrome tab works. Okay, so let's say, I'm gonna just go to a whiteboard here. View, let's do full screen, okay. Well, that's gonna have to work. So let's say you have a glycerol molecule. So this would be glycerol. And in the triglyceride, you have glycerol and 3 fatty acids, okay? So they would be coming from here. And each fatty acid is a link or chain of carbon atoms linked together, okay? And it would be the same here, okay? It would be these carbon atoms. But I'm just gonna draw one fatty acid here, fatty acid chain, and that would be this one. Carbon is an atom that likes to make 3 or 4 bonds, okay? So right now, the way I drew it, each carbon except for the last one has 2 bonds, right? And each line is a bond, okay? So this is a bond, this is a bond, this is a bond, right? So each carbon in this state has 2 bonds, except for that last one. So if it only has 2 bonds, carbons will bond hydrogen atoms, okay? So now this first carbon that I just drew these hydrogen to has 4 bonds, and it's happy. And every carbon in a fatty acid chain is going to be like that, okay? And then the last one, okay, so the H is hydrogen atom. And here we go. The last one is going to have 3, okay? So this is, let me get rid of this. Okay, this is what a unsat or saturated fatty acid chain looks like. It has the maximum number of hydrogen atoms possible. Okay, so this is, it's like all the carbons are fully loaded with hydrogens, okay? That's what saturated fatty acid means. And saturated fatty acids do not have any double bonds. It looks like this, okay? You have all these hydrogens there. And saturated fatty acids are usually a solid at room temperature, and they come from meat and milk and things like that, some oils. So this is a saturated fatty acid. But sometimes between carbons, there are different types of bonds. So instead of having a single bond between carbon atoms, sometimes there might be a double bond. So let's erase this bond right here and make this bond a double bond. Okay. So I'm right here, okay? As soon as there's a double bond that forms between carbons, carbon has to let go of hydrogen. It forms a double bond with another carbon. It has to get rid of hydrogen. It cannot have 5 lines around it. Okay, so this carbon would have to lose the hydrogen, and this carbon would have to lose the hydrogen. All right. So this is an unsaturated fatty acid because it lost a few hydrogens. Okay, so it has fewer hydrogens here. By the way, every time you create a double bond in the fatty acid chain, it creates a bend in this. So this actually would not be straight if you were looking at a 3D molecule. But every time you add a double bond, it changes the angle of the molecule, changes the geometry of the molecule, and that is what has to do with chemical properties of these molecules. But I think I'm going too much into chemistry here. Okay, so this is an unsaturated or monounsaturated fatty acid. It has 1 double bond in that fatty acid chain. But sometimes there's not just 1, but there might be 2 double bonds. Okay, if that happens, then some more hydrogens are lost and more bends are happening in these molecules. Okay, so this would be a polyunsaturated fatty acid, and polyunsaturated fatty acids are usually liquid at room temperature, and the unsaturated are also usually liquid at room temperature. Okay, so the saturated are usually solids. And so yeah, so this is polyunsaturated fat that it has multiple double bonds, and a bunch of hydrogens have been lost for that reason. And yeah, so anyways, that's kind of an idea of, I'm not gonna make you draw this on an exam or anything like that, but that's where that word comes from. Okay, saturated, if something is saturated, it is fully loaded. Okay, so that saturated fatty acid had all possible hydrogen, the maximum number of hydrogens that that fatty acid could carry. But as soon as you start adding those double bonds, you're losing hydrogens, so that makes it unsaturated fatty acid. Cholesterol is important for plasma membrane, and it is also, we're using cholesterol for making hormones as well as bile salts that we discussed in chapter 26. So cholesterol is not only bad, it is also very important in our body, and we'll talk about how or different types of cholesterol, or how the cholesterol travels through our body in a little bit. Proteins are very diverse molecules as far as structure goes, as well as function. So they are, you can have proteins that are enzymes, you can have proteins that are messengers, a lot of different things that proteins do. Proteins are made out of amino acids, and there are 8 amino acids that are essential, and there are 20 amino acids all total. So let me go back to you. Okay, so there are 20 possible amino acids, and then the different proteins are made of these amino acids in, like, you just link the amino acids in different order, different combinations. And as I said, the 8 of these amino acids are going to be your essential amino acids. So these are the ones that you have to come from diet, and then the other ones your body is able to synthesize, so you can make those in your body. Make sure that you know the list of the 8 essential ones. Okay, so they include your isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. Okay, so write them down somewhere, make a list, and make sure that you know that those are your essential amino acids. And again, essential amino acids come from diet. Non-essential, your body is able to make. So based on what kind of amino acids a protein is made out of, we can divide proteins into complete or incomplete proteins. Most of your animal protein is going to be complete. Okay, so what that means is that this protein is going to have all of those 8 essential amino acids in it. A lot of plant-based protein is going to be incomplete protein, because it only provides some of those essential acids, but not. There are only a few plant-based proteins that provide all 8 essential amino acids. I think quinoa is one of them, so that's a good one for protein. So the next section in the textbook is going to describe different lifestyles, different dietary lifestyles here, so you can see like vegetarian versus vegans. It is a little confused, as it starts with pescatarian, which is a person that does not eat red meat, but they would eat fish. But that's a type of vegetarian. And then it has a vegetarian definition, and then behind that, like after that, it has lacto-ovo-vegetarian, which again is a type of vegetarian. So the word vegetarian can have different meanings, whether, depending on whether it's pescatarian or lacto. It's just those 2 are types of vegetarians. There are several different subtypes. Okay, you can have an ovo-vegetarian, which is a person that does not eat meat, but they will eat eggs. Okay, lacto-ovo means that they are eating dairy products and eggs, but not meat. So again, that's a different type of vegetarian. Vegans are people that do not eat any animal products at all, and vegans can actually have some subtypes there as well, where you have like vegans that will just eat base stuff, but they will cook it. You can also have raw vegans, which is people that only will eat raw things, or things that haven't been heated above a certain temperature. So The thing with people that are limiting the intake of animal protein, though, is that they have to really pay attention to the type of amino acids that these proteins are providing for them. And so and that's because, as I've mentioned, the plant-based proteins are often incomplete proteins. So you have to make sure that your diet contains plant-based foods that are providing all of these essential amino acids for you. So that's our proteins. When we talk about proteins, we should talk about nitrogen balance, because proteins are a source of nitrogen, and nitrogen is very important for our body because we need nitrogen for new proteins. We also need nitrogen to synthesize DNA in our body. So we have to make sure that our nitrogen is in check. And so the little section on the nitrogen balance there talks to you about what nitrogen balance is. Nitrogen balance would be where the intake of nitrogen is equal to output of nitrogen. By the way we eliminate nitrogen out of our body, or how we lose it, is in urine, okay, converting into urea, uric acid. So that's if you have positive nitrogen balance, that means you have more nitrogen, you're taking in more nitrogen than you're losing or eliminating, and the opposite is the truth for the negative nitrogen balance. So if you're a negative nitrogen balance, you are not taking in enough nitrogen and you're losing it faster than you're taking it in. And this could eventually be fatal, because you wouldn't be able to produce enough proteins and enough DNA in your body if you're deficient, if this goes too far. So proteins are our third macronutrient. Now we're going to look at micronutrients, and you might not have seen these before. Okay, so this is something that's new. And so if we look at this table here, it shows us vitamins. So our micronutrients are going to be the vitamins and minerals, okay? We can divide vitamins into essential and non-essential, and we can also divide them into water-soluble and fat-soluble. The solubility, this is how this table is organized here. Your water-soluble vitamins are all these B's and the C, okay? So these are water soluble, okay? And I don't know why on this picture it doesn't say that, but in your textbook it does, okay? If you look at the table in your book, it says water soluble here, okay? How weird, I never noticed that it's missing that header. Okay, so these are water soluble vitamins, and I'm just know that it's B's and C. Okay, I'm going to make you memorize those scientific names for each of the vitamins, and most of them come from the same sources. Okay, meat, grains, eggs, greens. Okay, meat almost everywhere in here. Okay, you have the ones at the bottom: A, D, E, and K. I would like you to know for fat-soluble vitamins what the function of these vitamins is. So for vitamin A is necessary for proper vision. Okay, vitamin A is important for our sight. Vitamin D is necessary for proper calcium absorption, and so therefore it is going to be important in your bone health. Vitamin E is actually, it has a various functions, so we can skip vitamin E, and usually people don't even have deficiency in vitamin E, but it is important in a lot of different processes in our body. It also works with vitamin K, so you don't need to know the function of the E, but for vitamin K, you already know the function, because we already talked about vitamin K when we talked about vitamin K being important in the blood clotting pathway, okay? So that's our vitamin K. Now, why are we talking about them being water soluble and fat soluble? It has to do with what you do with these vitamins if you have excess of these vitamins. Okay, and by the way, these are all essential vitamins. Okay, if you have excess of water soluble vitamins, then your body just eliminates these water soluble vitamins in urine. So if you are overloading with vitamins and you use the restroom, you might notice that the urine is actually going to be different color, and it also has a gain a different odor. But you eliminate these water-soluble vitamins in urine, so you cannot really OD on these water-soluble vitamins. But the fat-soluble vitamins, because they're fat-soluble, you can't eliminate them in urine, and for that reason, these are actually going to be stored in your adipose tissue. So if you have excess of fat-soluble vitamins, your body will store them, which is okay, unless you have a prolonged excess of these fat-soluble vitamins, in which case they could potentially reach a toxic level. Okay, so those vitamins get stored in your body, and they could reach a toxic level if you have too much of vitamins for too long. The non-essential vitamins include things like NADH and FADH2, which we have seen in, I don't know which chapter it is, but whenever we talked about the citric acid cycle. So, those are some of the non-essential vitamins. We don't really think about them as non-essential or as vitamins, but they are vitamins as well. The minerals, so the next table is going to be our minerals. And what happened to my table? Oh my goodness. You know what I think I'm showing you? I am showing you the PDF from the pictures that I took off some of the writing. So these are the blank figures, and that's what I made the PDF out of. Oops. But anyway, so if you are looking at that at your textbook, on page 1087 is where you can find what these are. Okay, so we have our major minerals and trace minerals. The major, so minerals are inorganic ions. Okay, vitamins were organic molecules, but minerals are just ions, which are charged molecules, and we can divide them into major and trace. Major minerals, you need more than 100 milligrams a day. Trace minerals, you need less than 100 milligrams per day. I want you to know these, the major minerals. And so for here, you'd have your Ca, that's your calcium. Then we have chloride ion, okay, magnesium, okay, phosphorus, and this is 2 plus. Phosphorus is P3 minus. That's a 3 minus. And then we have potassium, sodium, and sulfur. Potassium is K plus, sodium is Na plus, and sulfur is S2 minus. So I'm just abbreviating. You don't have to know the symbol of it, just know the name of it. Okay, so these are our major minerals. We need a bunch of them. I don't know why sulfur says unknown, but they are putting it into a major mineral, but there it is. Yeah, anyway, you need 100 milligrams or more of these per day. And then the rest of them are going to be trace. So you have things like chromium, cobalt, copper, okay, iron. Notice that iron is going to be a trace mineral. So is iodine, and we know that iron is important for hemoglobin, right? It's that part that binds oxygen. But our body is going to recycle most of the iron, and that's why iron is in the trace category. However, iron is actually most common nutritional deficiency as far as ions go. Okay, so that's that. Now, iodine, that we need for thyroid hormone synthesis. Okay, and but again, our body is going to recycle a lot of the iodine, so it is in the trace category there. And so those are minerals, and minerals are important in a lot of different reactions. They're also important parts of molecules that are being formed in our body. Okay, so that's that. Now for section 27.4, okay, section 27.4 talks about the nutrition or the guidelines for adequate nutrition. Okay. So And Jessica, I did start a little earlier today just because nobody has been showing up on Monday, so I just went ahead and recorded this earlier. So anyway, hello. So for 27.4, this is our guidelines for adequate nutrition. We used to have food pyramid, which used to look like a triangle, like a pyramid, and it had like each section of the pyramid had or represented like how much of that food you should, or food category you should be consuming, with the tip being the least amount. But then somebody decided that they don't like the food pyramid, and so they changed it into that my plate. Hold on, do I have a picture of? Yep. Okay, so here is this my plate. And so this is what it looks like. So every time you sit down to eat something, your plate should look like this. So more than half of your plate should be fruits and vegetables. I know that I'm not really following this, but that's what we should follow. Okay, and then you should have some grains and proteins there as well as dairy, which a lot of people argue that dairy is not actually necessary. I don't know. Okay, that's what the government says you should be eating, like this. And I will actually post like a funny video on YouTube that I usually show to my students, how which shows you how this could still be misunderstood, if you want to misunderstand it. But anyway, so that's what it should look like. You can go ahead and check out that website, choosemyplate.gov. It has a lot of good information and tips about nutrition, although it is not, 100% great. I've had my students actually try to use the tracking software or tracking page where they would input their nutrition for like 3 days. And the reports that I got from that is that it was lacking a lot of different foods. So, but they tried. You can see the different recommendations for different age groups and things like that on here. So it does have a lot of good information if you are interested in your nutrition. The next section of that section of this section 27.4 is nutritional food labels. So that I think everybody knows what food labels look like. Now, what's important when you go shopping and you look at these food labels, what is important about these is that the calories that you see, oops, let me use a different color here. Okay, the calories that we see here are per serving, okay? So that's important there. Now, what you need to look at also is how many servings do you have per container. So it's always going to tell you how many servings are in that container, in that package that you're buying, and then everything down here is listed per serving. Okay, so the calories are per serving. When it says total fat, okay, that's going to be still per serving, okay, not per package. And then down here you see some of the vitamins and their percentages that you have. The calories usually, like on a lot of food labels, are really bold, so that you can see like, oh, this is only 230 calories. Again, make sure that you're looking at, how many servings are there in the container. So if you think that this package has 230 calories and you plan on eating the whole bag of whatever this is, you just ate 230 calories times 8. Okay, so always pay attention to the amount or to the number of servings that you have. And that's nutritional food labels. The clinical view talks a little bit about obesity, which it's kind of an increasing issue within the population here. And so you can read about clinical view, not required, but it's just something that you might find interesting. Let's talk about regulating blood levels of nutrients, and here we're going to be talking about the states, like absorptive and post-absorptive state, and what our insulin and glucagon are doing here. Okay, so if the absorptive state represents time of eating, digesting, and absorbing. Okay, so we don't need to be looking at the at the food level. Okay, so absorptive state is the time that you're eating, absorbing, and digesting, and it lasts about 4 hours or so. And during this time, we're going to see insulin being released. Insulin is going to be responsible for glycogenesis, for lipogenesis, and protein synthesis increase. This is because you are absorbing nutrients into the blood, so their levels rise, and so insulin is going to try to keep them within an appropriate level. And so you see glycogenesis, that's formation of glycogen where you're linking the glucose molecules together. A lipogenesis, you would be storing lipids, taking them down from your blood and storing them in the adipose tissue. And then protein synthesis increase because now you're getting this influx of amino acids into your blood, and so that can fuel protein synthesis. Post-absorptive state is going to be after you're no longer digesting or absorbing or eating, okay? And during post-absorptive state, your body is now using the nutrients, and so the nutrient levels in your blood start dropping, and so glucagon will be released. And glucagon is going to do the opposite of what insulin does. It is going to increase gluconeogenesis, it's going to increase glycogenolysis, so you break the glycogen into individual glucose molecules, and this is going to increase glucose in your blood so cells can use it now. You're going to see lipolysis as well, but the glycogen does not really have an effect on proteins, okay? Although insulin did, and we saw protein synthesis, glycogen does not really affect proteins much. So that's that. Okay, let me see. All right, I don't think I erased anything from this picture, and I do want to show you this one. So we talked about liver in chapter 26, like the structure of the liver, and the liver produces bile salts and does other stuff. So we're going to look at the function of the liver as far as the formation of cholesterol goes. Cholesterol does not only come from our diet, but it also can be made by hepatocytes in the liver. And this is a negative feedback. So if your cholesterol levels are low, the liver will synthesize cholesterol, okay? Because we need cholesterol for various things. Cholesterol is an important part of the cell membrane. It also, I've already said this, I think, at the beginning, but it also is going to be important in synthesis of steroid hormones and other things. So, so let's look at this cholesterol synthesis here. And I know it sounds like a lot of chemistry here, okay, but you can see your fatty acids. So remember me drawing that fatty acid, okay, right here. It would be attached to the glycerol there somewhere. But anyway, so we make cholesterol from fatty acids. And the process by which this is done is called beta oxidation. Beta oxidation is going to take your fatty acid into acetyl-CoA. Acetyl-CoA, well, we're going to see that in a minute again, okay? But acetyl-CoA is kind of like our intermediate molecule for a bunch of our nutrients, okay? So you can take a fatty acid and convert it into acetyl-CoA. And then from that acetyl-CoA, depending on what the levels are in your blood, what the levels of cholesterol are in your blood, you can see either decreased cholesterol synthesis, okay, and that's if, decreased cholesterol synthesis would be actually right here, and that's if your cholesterol is high in your blood, okay, or you can see increased cholesterol synthesis, which is this side, and that's if your cholesterol in your blood has decreased, okay? So you make cholesterol if you need it. If you don't need it, if you have high cholesterol, then your liver would not be making any new ones, okay? Cholesterol also is going to serve for our bile salts here, okay? And we already know what bile salts do. Bile salts are responsible for emulsification of lipids in our small intestine. So that is this cholesterol synthesis kind of in a nutshell. Now, since we're talking about lipid, we need to talk about transport of lipid. We know that lipids are not water soluble because they're lipids. Okay, so lipids are lipid soluble. And so the way that they travel in our blood, they can't just be freely floating around because they would be clumping together, right? And so in order for lipids to travel through the blood, we have to package them. So generally what you're going to see is a protein shell or protein coat, and this protein will be water soluble. So when you have this lipid inside of a protein, we call this a lipoprotein. And we've already seen a type of lipoprotein in chapter 26 towards the end, where we saw chylomicron. Chylomicron was how lipid is entering your lacteal and then gets into the lymphatic system and then ultimately gets into your blood. So we're going to actually divide these different lipoproteins based on how much protein they have and how much lipid they carry. So we can divide these lipoproteins into very low density lipoproteins. These are going to have a lot of different kinds of lipids, like triglycerides or cholesterol. Okay, they're not very selective, but they'll just carry various types of lipids. Okay, very low density lipoprotein. And the very low density lipoprotein in this picture is right here, okay? So what you might notice about this is that this structure has a relatively like a thin protein shell and a bunch of lipid inside, okay? And this is why it's called very low density lipoprotein. Lipid is less dense than protein, okay? So this guy is very low density. Then we have low density lipoprotein, and you can see that right here, okay? The low density lipoprotein has a little thicker protein shell, and it also is not going to carry as much lipid inside, okay? So it has a smaller, less space for the lipid there. So it's not as low density as the very, that's still relatively low density there. And the low density lipoproteins generally have a lot of cholesterol in them. These are the ones that carry cholesterol. And the low density and very low density lipoproteins, the direction in which they travel and where they take these lipids is going to be the ones that take it from the liver, take the lipids from the liver, and they're delivering it to cells, to tissues. The thing is, if you have a lot of these, sometimes they dump their lipid where they're not supposed to, and this could create plaque inside of your vessels if they're doing this in the vessels. So we have another type of lipoprotein, and that's the high density lipoprotein, and that's this one that you see right here. High density because it has a lot of protein, so the protein is pretty significant there, and for that reason you're also going to have a smaller space there for the lipids. So these are able to carry the least amount of lipid, and they have the most protein in them. And these high-density lipoproteins are the ones that take lipid from tissue and they take it back to the liver. So sometimes you might hear the term good cholesterol versus bad cholesterol. The high-density lipoproteins are generally the ones that people call the good cholesterol because they can make up for the low ones, dumping lipid in random places, okay? So, but really when you're talking about cholesterol, you really have to consider the ratio or the balance of these two. So individual number does not really tell you a lot about a person's health, and their cholesterol, you have to look at, do you have enough of those HDLs to make up for the number of the low and very low density lipoproteins. That's the important part, is you got to look at the balance of them, or the ratio of these two. All right, so that is cholesterol. The section on cellular respiration. You've already talked about cellular respiration and electron transfer, all the stuff in AMP1. What I do want to point out here, and I guess let me find the image here. Okay, yeah, I took off the the words for the picture I'm using. Let me see if I can find the actual image and not use the PowerPoint that I was using. So what is important to note from this citric cycle and really just cellular respiration is that we can actually interconvert between molecules. What that means is you can take a protein, you can convert it into glucose if you want to. That actually, that example is not the one that your body likes to do often, but it is possible, okay? You can take lipid and you can convert that into glucose as well. Okay, so let me find the image right here that is actually labeled, and here we go. It's uploading. So come on, load. It's being a little slow, but okay, here we go. Maybe, no, my computer is really, really slow today. And I don't see the image. Share. Okay, there we go. Okay, so now if we zoom into this, okay, this is the whole picture here. But what you can see here is you can take protein. You have to, like with the protein, and I said that we can convert protein into glucose. Okay, this is actually the process that your body likes to do the least, because in order to convert protein into glucose, you have to get rid of the amino group, and that's just an extra step that's a little harder for your for your body to do. But notice that if you take protein, you can take the protein and you can convert it into glucose, because the intermediate molecule that we see here is right here. So remember me saying, like, we can make from fatty acids, we make the acetyl-CoA. This is also the first step in making cholesterol too. The acetyl-CoA is like a central molecule that we do during processing of these nutrients. So protein will eventually become acetyl-CoA. Triglycerides can be converted into acetyl-CoA, as well as glucose, obviously, can be converted into acetyl-CoA. So these processes are reversible. So any acetyl-CoA that you have, you can convert back into any of those molecules there. And so that's so note that we can convert between these biomolecules, okay? So a high protein diet can still make you fat, okay? You can still convert this protein into lipid storage if you have too much protein, okay? Or too much sugar. If your body doesn't need that sugar at that moment, it will convert it into lipid and store it as lipid. Okay, so that's how that works. The last part of this unit is energy and heat, and really for this section, just know the definitions from this section here. So know what is metabolic rate. Metabolic rate is this is how we measure energy that we use in a given period of time. And we can talk about the basal metabolic rate, which would be at rest. So this is if your body is not doing any physical activity. And when you measure the basal metabolic rate, this is usually under certain conditions. So you have to define the temperature, you have to define various things, the oxygen levels, things like that, because that all is going to affect your metabolic rate. And we measure the metabolic rate by two ways that it's possible. One is a respirometer, which measures your produced carbon dioxide, and then we can use that number to figure out what the metabolic rate is. And this is an indirect way because you're looking at the respiratory system and how much of this carbon dioxide your respiratory system produces. Direct way to measure metabolic rate is by calorimeter, and calor means heat in Spanish. Okay, so it literally measures the amount of heat your body is producing. And generally, This is a water-filled chamber that you put the person into, and that water is it has a certain temperature, and then you directly measure how much that water has been warmed up by that person's body. So respirometer is more used because it's kind of easier. You don't have to dunk a person in a water chamber. So that's that. Now, total metabolic rate would be your basal plus any activity, so any increase in energy or a metabolic rate associated with the exercise. And this also depends on various things like how much food have you eaten, what are environmental conditions, as I said, temperature and oxygen levels, as well as the amount of your body makeup, how much skeletal muscle do you have. Your metabolic rate is going to be different than, depending on how much lipid or fatty tissue you have compared to the skeletal muscle. Okay, so that's going to affect it. So that's the terminology for the metabolic rate. And then our temperature, so metabolic rate is going to, the metabolic activity is going to produce heat as a byproduct. And so when we talk about metabolic rate, we should talk about temperature regulation as well. Because increasing or decreasing metabolic rate can be done in order to regulate body temperature as well. So our body can regulate temperature by nervous system control. So your hypothalamus would be detecting, receiving signals from various parts of your body. For example, like if it's cold, then hypothalamus receives signals from the receptors under your skin, and it sends a signal that says, okay, maybe initiates the shivering, which would increase your temperature, or the hairs on your skin would stand up, and that helps with temperature regulation as well, or increase in temperature. And then if you're hot, if the temperature is too hot, again, the hypothalamus detects this, so this is that nervous control or nervous system control. And as a response to hot conditions, hypothalamus would initiate opening of the sweat glands, directing blood flow to the capillaries under the skin, so we can release the excess heat and such. And so that's the nervous system control in a nutshell. And then we also have hormonal control. So there are different hormones that regulate our temperature as well. The most important hormone here is your thyroid hormone, because thyroid hormone directly affects the rate of metabolism. Okay, increased thyroid hormone increases metabolic rate. Decreased thyroid hormone would decrease metabolic rate. And so thyroid hormone is the most important one for temperature regulation. But there are other ones. Testosterone also is going to increase temperature, as well as epinephrine, norepinephrine also have a role in that. So higher testosterone means more heat. That's why men usually feel hotter than women. But thyroid hormone, most important hormonal control of temperature regulation. So that is chapter 27. Again, a lot of this is just a review. So you have heard a lot of stuff that is going on in chapter 27. And then towards the end is where we had some of the new stuff. So that's chapter 27.